Hi, everybody. Welcome to our talk. My name is John Jainschigg from Mirantis, and I'm joined by my colleague Nick Chase, who will narrate and deliver our demo. Our topic today is secure software supply chains for container development. The software supply chain includes everything necessary to deliver applications to production. This includes everything that goes into containers, application code, libraries, and third-party tools. It also includes the container host operating system and the container runtime, as well as any orchestration tools like Kubernetes that we wrap around containers to help them operate. There's recently been an increase in attacks that have compromised well-known software companies' supply chains, allowing attackers to potentially gain access to systems by injecting their own malicious code or backdoor capabilities into third-party systems and solutions, software components that then get incorporated into software and become exploits. The software supply chain has become a long, complicated, and tangled web of different software components that are all brought together to deliver required functionality needed for an application. This complex web allows developers to build applications faster and with lower effort, obviously, by using pre-existing tools and libraries available from myriad sources. The security challenge comes from this necessary flexibility, which allows attackers to potentially infect libraries or tools within the process, either during development or later on when components are updated. There are multiple vectors for insertion and infection. Key sources of this risk, outside of the kernel runtime and orchestrator, are components that are typically included in containers. These components usually come from three possible sources. There's application code, usually written in-house code and libraries, but could also include upstream open source applications that have been adopted. The risk here is that this code is often considered trusted and doesn't get the level of scrutiny that it probably should. Then there are vendor libraries and tools. These include libraries and tools that have shipped with the operating system, the runtime, or other vendor-delivered software. This category is probably, and we stress probably, but it still carries risk. The lowest risk category is this code is usually scanned and verified through vendors' supply chains. And then there are upstream libraries and tools. These are tools and libraries developed by the open source community, made available on GitHub or other platforms. This category is probably at this point our highest risk. We have a tendency to trust open source community software because of the idea that many eyes should pick up on anything malicious. But the reality is that there have been a number of direct attacks on open source repositories, or more subtle attacks where code has been slowly injected through the normal contribution process and has gone undetected for a long time. The recent sad business with the University of Minnesota and the Linux kernel is an example. While the risk has always been there in traditional software supply chains, typically it's been mitigated by software companies performing detailed security checks and extensively testing their software before shipping it out. But now, with the rise of more agile development processes and containerized applications, stuff that can be built, tested, and productionized right on the fly using technologies like Docker Compose or Helm to define complex application sets and Docker files to quickly and easily define what's needed to automatically build each container, plus CI/CD solutions to build and test and push applications to production much faster, we have changed and increased the places that vulnerabilities can be introduced. So, to mitigate the risk of someone injecting unwanted code into our applications, we need to change the way we think about trusting our code. Essentially, we need to become more paranoid. We can no longer trust anyone in the supply chain, and we need to be able to verify and scan everything at every stage of the process. In addition, once we've verified code and built images, we need to verify the images and securely store and sign them so we can be sure that the images we're storing are the ones we approved. There's a chain of trust that needs to be created around these artifacts, and we have to be able to maintain and prove their provenance in order to feel safer. Lastly, we need a way to ensure that we can only run the images that we have approved, and that images that have not been through the approval process can't be executed on, at least on production environments, or indeed any environments should we choose. With that, I'm going to hand you over to Nick Chase, who is going to explain and demonstrate a practical application of a secure end-to-end software supply chain.
Thanks, John. So that's the theory behind what we're trying to get. We're trying to get a software supply chain where nobody has a chance to sneak in anything that we don't actually want, whether it's intentional or unintentional. So what we're looking for is images that are scanned, tested, reviewed, and verified. Well, what does that mean? So for images, we know how to do that. We know how to build code with Jenkins. It's just like we've always done. Once we have those images, we want to make sure that there are no vulnerabilities. So we can scan them for vulnerabilities in a specific registry, a secure registry like Docker Trusted Registry, which is now called Mirantis Secure Registry, or Harbor, or any one of those secure registries. And then once we know that we don't have a bunch of vulnerabilities in there, we can go on to the testing phase. So in the testing phase is where we're going to go ahead and run tests with Jenkins just like we normally would. We'll run unit tests, we'll run integration tests, we'll do all of the things that we've always done. And then once those tests are done, we can sign those images to verify that they've actually been tested and scanned, and then we can make sure that before we run them, we verify that they have been signed. Okay, so let's look at how we make that happen. Okay, so at the beginning of this process, we see we can, after we're done building the code, we can send it to the registry for scanning. So we can do this part of that process. Once we've scanned it, we can promote it over to the testing stage. And then once we have run that testing, we can take those successful tests, send them over to be signed. And then once they're signed, we can check them back into the registry so that they can be used by actual applications. And as part of that process, we set restrictions to make sure that only signed applications can run. Now, let's take a look at how that actually works in practice. Okay, now if we start back at the beginning, building code with Jenkins, that looks like you would think it would look. We have a code repository here in GitHub. We've got a Jenkins file that controls what's going to be done. And that Jenkins file is going to build it. We're going to go into the actual Jenkins file in a little while, but we have an API that will be called by the user and a database. It's a simple application. We also have a Helm chart that deploys this application. It's nothing fancy. It's just something to show that everything works. And it's essentially, you check it out, you build it, you clean up. That's all there is to it. Now, when we go to scanning for vulnerabilities, then we go into the Mirantis Secure Registry. In this case, again, you can use whatever you want, Harbor, whatever. But in our case, we've got, this is the registry. It's got a number of different repositories. The API build repository is where we're starting out, and it's set to scan when tags are pushed. So you can see here, we've got tags that are pushed. We can look and see what vulnerabilities they have. In this case, you can see we've got several, not too bad considering, but we have, say, OpenSSL has a number of different ones, and we can see what they are. We can read descriptions of them, and we can even see what layers those vulnerabilities came from. So if we wanted to, we could go ahead and fix those vulnerabilities. So, all right. So that is the vulnerability part. Okay. Now, running unit tests and integration tests with Jenkins, that's probably the one thing everybody has seen before. We've got our testing pipeline. As you can see, we've got our unit test section, our integration test section, and then we're ready to actually go ahead and sign the images, which in this case we're referring to as finalization. So we can do all of that in one pipeline. Obviously, we're not going to worry about it if these fail up here. So once we've finalized it, we can then go ahead and deploy it. And we want to make sure that only the signed images run. So we can come back to Mirantis Kubernetes engine, which formerly known as Docker Enterprise. And again, you can do this with your own tools. We want to set it to run only signed images, and we could set it to only from the engineering organization and the CI team. We got to make sure that they sign off on it. You could also add additional teams. So for example, if you wanted to say, okay, you know what, the data center team has to sign off on it also. Data center organization. I don't have any teams in here, but you get the idea. And this is how we can set it up for even management approval. So you might have a pipeline that requires management approval. All right, let's look at how we are going to tie this all together. Okay, so let's look at how the code gets into the registry for scanning. So if we look at the actual Jenkins file, what we're going to see is that there's a couple of different steps being taken here. First off, we know we need to do scanning, but later we also know we're going to need to do testing. So we're building three different images. We're building the release candidate, which is just the application, nice slim image. And we're building the unit test image, which has the unit testing framework in it, which we don't need in the RC. And same thing for the integration testing framework. And then we're naming these images based on the minor and major version numbers and the build ID. That's really important so that we know what to act on later. And then once we have those images, we're logging into the actual repository. In our case, it's a secure repository, but it could just be Docker Hub, or it could be your own secure repository, Harbor, whatever. And then we're pushing them to the image registry. All right, so then once that's done, we can move on to scanning. And then once we've scanned for vulnerabilities, how do we promote these images to the testing stage? So if we go look at the build directory, build repo, it is set up so that it looks at promotions, and it can do promotions to, in this case, the API test repo. And that is based on rules, which we can take a look at. So if we look at the rules, what it says is if this repo has an image that starts with unit test and it has less than 20 vulnerabilities, then we want to promote this image to the test repo. Now, you may be thinking, why only this one? Well, if you go to the API test repo, the API test repo isn't really doing the testing. All it's doing is when a tag, any tag, is pushed to this repository, then it's calling a webhook. And the webhook is calling back to Jenkins, and Jenkins is doing the actual testing. So all we're really doing here is kicking it off. So, all right, so we kick it off. We go up to, we go back to Jenkins. We go to the Jenkins file in this case. And this one is a little bit more complicated because it's doing a few more things. So we know that it's doing the unit testing. We can see it's doing the integration testing. We can see, and then after it's done the integration testing, if everything passes, we want it to do the finalization step, which is actually the signing of the content. Okay, so you can see that all in here. And then we're going to push it back to the repo. In this case, we're pushing the Helm chart back Mirantis Secure Registry did not used to be able to take Helm charts. It can now. So we're going to push the Helm chart back. So now we've got everything back into the repository so that we can go ahead and deploy it. And in this case, we're going to deploy it to the staging namespace, as you can see here. And then we already set the restrictions on how these can run, so we don't have to look at that again. So we've got that all tied together. Now let's see it all in one piece. Okay, so now let's see this whole thing in one shot. So if I were to go ahead and, in this case, I'm going to do a simple edit of the README file. I'm going to cheat, and I'm going to do it in the GitHub interface because, you know, I'm being lazy. So I'm going to come by, commit the changes, and all right, so that should kick everything off. So let's go take a look. If I come over here to the build server, we started with build number 15. So build number 16 should start any second. Come on, 16. There it is. Okay, so build 16 has been kicked off. And we start to see the individual tests. There we go. All right, so 16 is the important number here. Everything that we do is going to be on image number, build number 16. So we got through our initial tests. So now let's see if it made it over to the build registry. We look under tags. There it is. There's all three: integration, unit test, RC, build 16. We can see they're scanning. This is going to take a little while to do an updated scan. Sometimes it can take a few minutes. So what I'm going to do is I'm just going to go ahead and promote it directly so we don't have to sit and wait for it. We know that it needs to go to the engineering API test, and we need to have a name for the target in there because, again, everything is based on that name. So I'm going to put in the proper name of the tag. Go back to the repositories. So that goes into the test repo. Okay, that calls the webhook, remember, and then that triggers our Jenkins pipeline. Here we go. We've got our unit test running. It's going to run our integration tests in a second. Or maybe a couple of seconds. There we go. So integration tests are in progress. Takes a few more seconds, but this is a live test, so there you go. And finalization, remember that's where we're going to go ahead and sign the images. So that takes just a few seconds as soon as we get there. There we go. And then we go ahead and deploy it to staging, and we should be all done. So at this point, we should be able to see the application in the staging namespace. So let's take a look. We're going to make sure the namespace is there. Yes, it is. Okay, so there's our staging namespace. Okay, now let's get the pods that are in the namespace. All right, here we have two different pods. We have the database and the actual API that people are going to call. Now, this is stored in that same repository, but it's actually being stored. Let's take a look. Let's go back to the registry. So if we go up to repositories, you can see here, there's image 16 and it's signed, and that's where it gets called from. So kubectl, we're going to get the services, so we can pull this up ourselves. Staging, API ingress is what we want. You can see the database there, but that's just internal. So ingress is a node port service running on port 32110. So let's do curl. We got the URL here. That's the IP for the machine. We've got the port, and then the URL to actually pick up a product. So if we go ahead and pull that out, we can see we get back a product. We call a different ID, a different product. I mean, it's just a toy database, so you can see what's going on, but that is the general idea. So everything is working, which is always a good thing. All right, so thank you so much for your time. And if you have any questions, please go ahead and contact us at www.mirantis.com/contact. We always love to hear from you, and we like to hear what you have to say about this process, or if we can help you with anything else. We always like to hear from you. Thank you all very much, and thank you, John. And thank you very much to Sean O'Mara for helping us with a lot of the foundations for this, and to Bill Mills for his technical assistance with the demo.